problem is much more like 9 and 10 than it is like 11. Starting off with our reaction, if MgO is forming, that's going to happen from its pure elements. Oxygen's a diatomic, so it gets a 2. I would normally just balance this with a 1/2 here. If you want to balance it, otherwise you can. Most of you probably balance it like this, so I will do that. Okay. If you balance it like this, never mind. You can balance it like this. Finding my heat of reaction, products minus reactants. So 2 times the value of MgO, negative 601.8, minus pure element 0, pure element 0. So really it's just 2 times negative 601.8. 2 times negative 601.8. I get negative 1203.6 kilojoules per mole. That's the heat released, because of the negative sign, for every mole of MgO that I use. But I have a different amount of heat. So, kilojoules per mole of MgO, kilojoules per mole of MgO. The reason I'm using MgO rather than Mg or O2 is because they ask about MgO forming. So I want to find how many moles of it formed, therefore I can find the mass, the grams. That's if I used 200 kilojoules. Heat for this mass, oops, I don't need the negative sign. Heat for 2 moles of MgO. If you had balanced your reaction the first way I referred to, so a 1, a 1/2, and a 1, your heat of reaction would have just been 601.8 because you never would have multiplied by this 2. So you would have had 601.8 over 1 because you would have had a coefficient of 1 in front of the MgO. Mathematically, that's the exact same thing. So that's why either way works. Cross multiplying. For X, we get 0.33, and that's my moles of magnesium oxide. Grams equals moles times the molecular weight. Molecular weight is 40 times that 0.33. We get 13.29, or 13.3 grams.